Now, if I go from C, then I have only two choices, towards A or towards B, but I can see that we have more carbon atoms from the A and B structure, right? So I will start from A or B, you can start. And this will be your parent carbon chain. This will be your parent carbon chain, okay? And if you want to number the parent carbon chain, so you will number it from the carbon atom that is nearest to functional group. There is no functional group. Then double bond, there is no double bond. Then triple bond, there is no triple bond. So you are going to number it from the carbon atom, which is directly attached, nearest carbon atom that is directly attached to the substituent. Now this is my substituent here. So the numbering will be something like this. 1, 2, 3, 4, 5, 6, right? So this is the way of numbering. There can be only two ways of numbering. Okay, once you have a parent carbon chain, so you can number it like this, as we numbered 1, 2, 3, 4, 5, and 6. Or you can number it this way: 1, 2, 3, 4, 5, 6. As you can see, the substituent in the pink color, it is coming at the third carbon atom, and in the blue color, it is coming in the fourth carbon atom. Now, this is also known as the lowest locant rule, which says that the substituent should be present at the least carbon atom. Number should be present in the least carbon atom. If there is a substituent, if there is a functional group, so functional group will get priority. But we will keep a very simple rule in our mind. Start numbering from that carbon atom which is nearest to functional group, if not double bond, if not triple bond, if not the substituent. Now moving on to the second structure here. So the functional group is going to be E because we don't have any. Here we have 6 carbon atoms, so I will name it as hex. Okay. Then here we have no functional group, so again E, and then we have a double bond, so it will be En, and then we will start the numbering from that carbon atom, or we will choose the parent carbon such that it contains the double bond. So our parent carbon chain will be something like this, 1, this way. So here we have how many carbon atoms? 1, and the numbering will be done from the carbon atom that is nearest to the double bond. 2, 3, 4, 5, 6, and 7. So this is hept. Now, if you look at the next one, then here you don't have functional group. Here also you don't have any. Here you don't have functional group, and here you don't have any double bond or triple bond. So longest carbon chain is your only option, and the longest carbon chain can only be this 5 carbon atoms. If you choose this one, it will be only 4. So third number में देखते हैं how many of you have done it correctly, because third number is a bit tricky. चलिए print लिखना है, very good. Rabia has done it correctly. Mariam ने ब्यूट लिखा है. So please understand that. I understand that आप लोगों को ये लग रहा होगा कि maybe BR is a functional group, but you know that BR is not a functional group. Okay, BR is not a functional group. So here you will have E. That is your functional group. There is no functional group, so E and AN because of double bond and triple bond, and then you will have pent. Okay, so even though in the context of reactions, BR is a functional group, but in the context of IUPAC nomenclature, BR is not a functional group as it is not present in the list of functional groups. Is that clear? Yes or no? Please tell me, guys, all of you. Mariam Khatun, खास तौर से आपको clear है? Mariam Khatun?
Yes, sir.
Okay. Thank you. Assalamu alaikum. How are you?
Walaikum assalam. How are you?
I'm good, alhamdulillah. बहुत दिनों बाद कहाँ थे आप इतने दिन? घूम रहे हैं अभी भी?
नहीं, मैं कतर आ गई सर.
अच्छा, कतर आ गए आप. चलिए ठीक है. चलिए इसमें बताइए फिर what will be the functional group in the fourth one? Okay, fine. I see a bit of mistake in Mariam Khatun's work. Yes, OH is the functional group, right? So it will be all. Now you're going to take the complete carbon chain. Na? ऐसे रुकना नहीं है. You'll start from here because that is the carbon atom nearest to the functional group. 1, 2, 3, 4, 5, 6. You don't have to stop. Why are you stopping? Okay, Mariam Khatun, you got this? Okay. So end से end तक होता है बिल्कुल terminal से terminal तक. Okay. In the fifth carbon atom we have ol, and this will be AN, and here it will be hex. In this case it will be again E because there is a there's no functional group. Then there will be En, and for the parent carbon chain I will start from here. This is the parent carbon chain. So it will be 1, 2, 3, 4, 5, 6, and 7. So it will be hept. Now in the sixth case, it is a bit tricky. So you just need to get, you don't have any double bond, triple bond, or functional group. So it will be E, A, N, and the parent carbon chain. I think that this will be the longest carbon chain. With 1, 2, 3, 4, 5, 6, 7, 8 carbon atoms, it will be oct. खातून आपको समझ में आ रहा है आपने आधे आधे में क्यों छोड़ा हुआ है? You will start और end होना चाहिए last carbon atoms में ना? Got it, खातून? Okay. Similarly, in this structure, again, you have to choose the longest carbon chain. I think this is the longest carbon chain. It will be 1, 2, 3, 4, 5, 6, and 7. Now here you have a functional group. So functional group is own, because here you have double bond oxygen, and it is attached with CH3. And then you have also a double bond here with carbon atoms. It will be En. And if I talk about the parent carbon chain, so this will be like this. We'll go this side. So here you have 1, 2, 3, 4, 5, and 6 carbon atoms. That means it is hex. Now in the ninth one, it is important. And ninth wale mein aapko dekhna hai. What is the functional group? Functional group is oic acid. Functional group is oic acid. And then you have double bond as well as triple bond. है ना? Double bond भी आपके पास है, triple bond भी आपके पास है. But once you have functional group, तो आप यहाँ पे देखिएगा, the parent carbon chain is going to be something like this. Because once you go at this carbon atom, you can either move towards the double bond or the triple bond. So obviously double bond gets the priority, so it will be something like this. है ना? Because we have 1, 2, 3, 4, 5, and 6 carbon atoms. So here you will have En, because this triple bond is not coming inside the parent carbon chain. है ना? ये बहुत ही complex वाला question हो गया है. You will not get this much type of questions, but again, I'm just giving you guys here so that you understand. ठीक है? इस तरह भी होता है. En and the parent carbon chain will be hex. So ninth में I see Mariam Khatun, why you have written di-En? There is only one double bond, no? There are not two double bonds. देखिए सिर्फ एक ही तो double bond है carbon carbon के बीच में. And similarly for the eighth one also you have done it wrong, Mariam Khatun. See, for the eighth one you have to include the double bonded carbon atoms, right?
Yes, sir.
And then you have also done it wrong in the seventh one, longest carbon chain आपने नहीं लिया है. यार बीच में ही रुक जा रही है. I don't know why you are stopping at the middle, है ना?
Yes, sir.
ठीक है. Actually, those who have not done, please write this down. Let me know once you're done, and then we'll move towards the substituent. Is anyone still writing? Please let me know. Is anyone still writing? No. Fine. Okay. Right, next. Substituents. Okay. So substituent, mainly you can, what is first of all substituent? So please write that. Whatever remains after the identification of parent, unsaturation, and functional, whatever remains after the identification of buff is called substituent. is called substituent. Now, if I talk about substituent, so I will give you an example. For example, you have some structure like this. Okay, so we'll start by identification of puff first of all. That means functional group is equal to what? Here you have CHO, so it will be Al. Then you have the unsaturation. Yes, there is unsaturation, so there is a double bond. That means it is En. And if we talk about the parent carbon chain, so it will start from this carbon atom 1, 2, 3, 4, 5, and 6. 1, 2, 3, 4, 5, and 6. The parent carbon chain is 6 carbon atoms. That means you have hex. Now, whatever is remaining after this, okay, whatever is remaining, that is called substituent. So, kya bach gaya hai? So, CHO we have done identification as functional group. Now, things which are remaining is this OH group, this CH3 group, and this Br group. Okay. Now, these are the 3 different types of substituent that you are going to get. सबसे पहले तो आप यहाँ क्लासिफाई कर सकते हैं that there will be alkyl substituent and non-alkyl substituent. So what are alkyl substituent? Alkyl substituent will contain only carbon and hydrogen. Okay. So for example, this methyl is a what? Alkyl substituent. And then non-alkyl means bromine and OH. These are non-alkyl substituents. Now, within the non-alkyl substituent, what you can classify? OH is present in functional group list and Br is not present in functional group list. Okay. So you have a classification in your head also. So it will be easier for you guys to remember. Okay. तो आपको बस अपने दिमाग में बस वही पार्ट में जाना पड़ेगा. You have to go into that only that part which contains the alkyl substituent. If you want to name the alkyl substituent, if you want to name the non-alkyl, then you will also see which part, whether it is present in functional group or whether it's not present in the functional group. Okay. So first of all, I will classify the substituent into 2 parts. One is alkyl substituent. And the other is non-alkyl substituent. Okay. So what is alkyl substituent? It contains only carbon and hydrogen. Here can also contain atoms other than carbon and hydrogen. Okay. Now, first of all, I will look at the alkyl substituent. That is also a big list. या फिर एक काम करते हैं नॉन एल्काइल को पहले देख लेते हैं because it is a small list है ना. Then we will look at the alkyl substituent which is a big list. First of all, you are going to write non-alkyl substituents. Okay. Non-alkyl substituent. Now, in non-alkyl substituent, you have substituent. Substituent in the list of functional group. Now, what are these substituents? So we have done this in the first class itself, right? So if you have, for example, OH acting as a substituent, then you will write hydroxy. If you have NH2 acting as a substituent, then you will write amino. If you have ketone, that is own group that is acting as a substituent, then you will write oxo. Similarly for aldehyde, nitrile, amide, and then ester and everything. Okay, so that is one thing. Substituent in the list of functional group. So we have already written that. We are not going to repeat that thing. What is the another one? The another one is substituent not in list of functional group. So these are very few. You can easily remember it. First of all, you have the halogens. So halogens will be named as halo. Now, for halogen, you have fluorine, right? So fluorine ki jagah, I will write it as F. So if you have F attached, then you will write fluoro. If you have Cl attached, you will write chloro. If you have Br attached, you will write bromo. And if you have iodine attached, you'll write iodo. So this is all about iodo halogens. Then you have some other, for example, you have NO2. NO2 is nitro. And then you have OR. OR is alkoxy. What is the meaning of alkoxy? For example, इसी में example लिखिए. For OR, you can have OCS3. R is any alkyl group. So you'll have OCS3, for example. Now, CS3 means meth. So meth oxy. For example, if you have CH2CH3, this will be eth oxy. Eth is for the 2 carbon and oxy. Is it clear? Yes or no? Please tell me, guys, all of you, regarding alkoxy and everything. Yes, please tell me, guys. Is this clear? So
Yes,
what
sir.
happened? Clear, na? What about others? Deborah, Iram, Fia, Hafsa, Madiha, Rabah, Tarif, all of you guys. Is this clear? Yes or no? Please note this down. Okay, it's very easy. We'll do some problems and then we'll move to the alkyl substituent. Okay, alkyl substituent may seem easy, but it gets a bit complicated if you have certain non-trivial names. Can you scroll up? Yeah, for sure, I can scroll up. You write this down. Let me know once you're done. Please let me know once you're done, guys. Done. Okay. Is there anyone who's still writing? Please say yes. Is there anyone who is still writing? Please say yes. No, no one is writing. It's fine. Write the IUPAC name for following. Okay. So, for example, if you have something like this, here you have Cl. So it's very simple. You have functional group. Functional group is what? Tell me, guys, all of you. What is a functional group? You can write in the chat. You can also scream. You can turn your mic on and tell me, or you can write in the chat. Yes. Functional group is what? Very good. OL. What about unsaturation? What about unsaturation? There is no double bond or triple bonds. It will be AN. And now what about the parent? So parent will start from its carbon atom. See, here you have 2 terminal carbon atoms. Huh? So this will be the only parent. You don't have any other choice. Okay. So this will be the only parent. Now, once you have got the parent, which is bute, then you will look at the substituent. So OH we have already done as functional group. So what is remaining? Only Cl. So for Cl, what do we write? What do we write for Cl? Chloro, right? That's it. Now what you need to do, you need to just number it. So numbering will start from the carbon atom that is nearest to the functional group, right? So numbering starts from the first carbon atom. So you'll number it here 1 as any. Please understand that when I say numbering starts with the carbon atom that is nearest to the functional group, please don't write 1 here. Okay, it means you have to number the parent carbon chain and the numbering kaun sa side se start hoga? A side or B side? Tell me guys. Where should the numbering start from, A or B? Yeah, A side, huh? Because A side is nearest to the functional group. Okay, so I will start numbering from here 1, 2, 3, and 4. So now chloro is in which position? It is in the 3rd position. And all is in which position? All is in the 2nd carbon atom. So you'll write 2 all. So what will be the name? It will be 3-chloro butane 2-ol. Is this clear? Yes or no? Please tell me.
Yes, sir.
Okay. Moving on, please see. Second question. Okay. Now, please, we will not try this. We will slowly do this. Okay. So first of all, we don't have to worry about anything. We just need to look at the functional group. So what is the functional group here? Tell me, guys. What is the functional group? In the chat, please. In the chat. Others, please answer. Here you can see 2 functional groups. What are those 2 functional groups? You can see OH and you can see also the ketone. So which will have higher priority, alcohol or ketone? Which will have higher priority? Now, one thing, please keep it in mind. As soon as you see double bond O, please focus on that double bond O. Okay. As soon as you see double bond O, most probably that is going to be your functional group itself. Always, whenever you have double bond and triple bonds. So if you look at the priority order, let me give you a look here. See, the first structure has double bond O, second structure has double bond O, third structure double bond O. The fourth structure had triple bond N. So whenever you have multiple bonds, please focus there. Then 5th carbon double bond O, 6th carbon double bond O. So most of the higher priority functional groups, they are having double bond or triple bonds with a hetero atom. That means either with oxygen, mostly with oxygen and only once with nitrogen. Okay, so whenever you see a double bond, please focus there. That may be your, most probably that may be your functional group. So what is our functional group? It is own. That is not only own, but since there are 2 times double bond O, C double bond O, so I will write dione. Now, whenever you write the functional group and everything, please have a margin here. Okay, so you please have a margin like this, so that you can write the numbers later. Okay, so it will be dione. Now, when we talk about the unsaturation, so what will be the unsaturation here? Please tell me, guys. Is there any carbon-carbon double bond or triple bond? Please tell me what will be the unsaturation. Fia, can you please explain me why? Fia, can you please explain why?
Yes, sir, because there are 2 double bonds, so we can write diene.
Yesterday only I told, right? I think you have to reread that part. That when we talk about unsaturation, please can you read that part? It tells about the presence of
Double bond and triple bond between carbon atoms.
So you want to change your answer now? So it is not between the carbon atoms, right? It is between carbon and oxygen.
Yeah, so it is AN.
AN only. It will be AN. There's no double bond or triple bonds. Now, when we talk about the parent, I will start from, see here. You have to identify the terminal carbon atoms. So here you have this terminal carbon. After this, you don't have any carbon atoms. That means this carbon atom is not attached to any other carbon atom. Similarly, this carbon atom also. It is next attached with oxygen, but not any other carbon atom. Similarly, this one is also a terminal carbon. That means it is attached to nitrogen. After that, you don't have any carbon atom. Is that clear? Yes or no? Please tell me. How to identify the last carbon atom? A carbon atom that is attached with carbon atom only through one side. Only through how many sides? Only through one side. If you look at any other carbon atom, for example, this carbon atom, it is attached with carbon atom on both these sides. Can you see that, all of you guys? Just please tell me. So tell me here, I have 3 terminal carbons, A, B, and C. Where should I start the numbering from? Where should I start the numbering from? Or what will be included in the parent carbon chain? Tell me. A, B. See, A, B cannot go anywhere else because we have only one carbon atom here, right? So, not talking about where to start from, but I can at least say that BC is going to be your parent carbon chain. Is that clear? Yes or no? Please tell me. That BC, no matter what the numbering is right now, we will not consider the numbering. We will consider the numbering only after we have written the substituents. Okay. So from here we can say that from B to C, and from B to C we have how many carbon atoms? We have 5 carbon atoms. So it will be pent. 1, 2, 3, 4, and 5. Now, after pent, we have to look at the substituent. Now, what is remaining here? The remaining parts are NO2. The remaining part is OH, and the remaining part is OCH3. Remaining part is OCH. Let me color this with something different so that it is differentiated from, yeah. Now I will start from here. So here we have oxygen with 1 CH3. So this will be methoxy. Here you have OH. So its substituent name is what? Please tell me, guys. For OH, what do we write? As substituent, when OH is as substituent, what do we write? When OH is acting as a substituent, then what do we write? Others, please answer, guys. What happened? Mariam Khatun, Deborah, Iram, Fia. When OH is acting as a substituent. Afsa, Madiha, please write. Afsa, did you watch the lecture?
Yes, sir.
Okay, so tell me. Yes, very good. This is hydroxy. And what is NO2? NO2 is very simple. We have just written it is nitro. Okay, so here you can see that H comes first. So what comes at last? JKLMN. So nitro. Then you have methoxy. And you have hydroxy. Okay. Now, now we have to number it. Now, what we need to do? We need to number it. So there are only two ways of numbering something. There are only 2 ways of numbering a parent carbon chain. The first is 1, 2, 3, 4, and 5. The other way of numbering will be the other way around. So we'll take some other color. Let us suppose we are taking red color here. So 1, 2, 3, 4, and 5. Now, if you look at the dione, the functional group is getting the same numbers in both the cases. If I do the coloring of, if I take the numbering of the white side, it is getting the numbers 2 and 4. If I take the red one, it is also getting 2 and 4. So that, I mean, from functional group, it doesn't matter what number you take. You can take the white one as well as the red one. But that doesn't stop at functional group. You have to look at the double bond. It should get the least number, then triple bond. It should get the least number, then substituent. So when I look at the substituents are also getting the same numbers, 1, 3, and 5. Then you have to put into the consideration of what? You have to put into consideration the alphabetical order. That means the substituent which is coming first in the alphabetical order, that should get the least number. That should get the least number. Now, if you look at the first substituent which is coming in this alphabetical order is hydroxy, and hydroxy is getting 3 for both the cases. Then you have to look at what is the next one. So hydroxy ke baad aata methoxy. Methoxy should get the least number. So methoxy is getting 1 in the white case and 5 in the red case. So I will number it in the way of white one, not the red one, because I have to give methoxy the least probable number. So methoxy is getting either 1 or 5. So what is lesser? 1 is lesser. So I will consider that one. JKLMN. No? Yeah, correct. So I have given you complete thing wherever there is a tie, what to do and what next to do. So hydroxy is 3, methoxy is 1, nitro is 5, pent, we don't number it. Unsaturation, there is no unsaturation, so we don't have to number it. Dione, so I will write 2, 4. So here you learn about a few things more. One more thing that you have to remember here. Whenever the functional group starts with the di, tri, tetra, then unsaturation becomes A and E. I will write that note for unsaturation also and functional group also. Whenever it starts with di, tri, tetra, then the unsaturation becomes A and E. That is suffixed by E. Similarly, if the unsaturation becomes diene, triene, or diwine, triine, then the parent becomes penta, hexa, hepta, and so on. Okay, so I'll write that point, don't worry about it. Now let us write the name here. So properly you have to write, first of all, you will start with the substituent, which is having the first alphabetical order. In alphabetical order, it will be 3-hydroxy.
Sir, I have a doubt.
Yes, tell me.
You said according the substituent which gets the first in alphabetical order gets the least number. So according
Yes,
to that, H comes before M, right? So it should be
no, no, no,
1
wait.
hydroxy, 2 methoxy,
No, no,
and
no, wait. We have only two options now for numbering. I have to number the complete parent chain. So first you will number it. Okay. So I can either number it this way or this way. Correct.
yes, sir.
Now you have to decide. So we cannot see hydroxy is getting 3 in whatever you take, the white numbering or the red numbering. Correct.
Yes, sir.
Okay. So that means the deciding factor is not going to be hydroxy, right? Okay. Otherwise, if you see, the first criteria is that functional group should get the least number, right?
Yes,
So
sir.
what is the meaning of least number? It is not in comparison to the other functional group. Sorry, it is not in the comparison to the other unsaturation or the substituents. It is in comparison to the whatever options you have. So I have only two options here for numbering, either the white one or the red one. So in those cases, I have to, in both of these options only, I have to see in which of the case rather, functional group is getting the least number. So right now it's same. Then I went to I would have gone to unsaturation, but there is no unsaturation. So I went to substituent. Now in substituent also, they are getting the same numbers. Then I have to go to alphabetical order. When I went to alphabetical order, I saw that hydroxy is getting the same number, 3 in the red case and the white case also. So I cannot choose according to that. So I went to the next one. So methoxy is getting 1 in one of the cases and it is getting 5 in the other case. So I will take the less number, 1, white one. Got it, Fia?
Yes, sir. Understood.
Understood now? Okay. So 3-hydroxy, 1 methoxy, and then you will have 5 nitro, pentane, 2,4 dione. Okay. Even though if you look, this is a so big name, but when you do it in very sequential way, part-wise, then it becomes very easy. So this would be one of the most complicated examples that we would have ever done in 11th standard and the 12th standard. Now in 11th standard, you have more complicated problems when you have to use brackets and all. That is not being used in the 12th standard, so I will not teach that right now. Okay, because when you have substituent inside substituent, so for example, you have something like this 1, 2, 3, 4, 5, and let us suppose you have here something like this, one more carbon atom. You have something like this. Okay. In this case, this is a substituent, and inside substituent, you have substituent. So that case becomes very complicated. You don't even need that. Okay. So don't worry about that. You will take those only which are useful in the 12th standard. See, everyone is done. Yes or no? Please tell me. All of you wrote this down. Please, please understand this and write this down. Okay. So done written. Okay. Hafsa, you understood this? Yes or no? Please tell me, Hafsa.
Yes, sir.
Okay. Fine. Now, there's a point that I want you guys to write. From this only we understood that whenever we have di, tri, tetra, then the unsaturation becomes A and E. So right here, if di, tri, tetra, etc. are used in functional group, then unsaturation becomes ene, ene, or ine. No, that is suffixed by e. Similarly, if di, tri, tetra, etc. are used in unsaturation, then parent becomes buta, penta, hexa, etc. That is suffixed by a. Please write these 2 points. Let me know once you're done writing. Yeah, done everyone. Fine. Okay. Now, let us move on to the alkyl substituents. That is more important. This is you can do this very pretty easy. So, you will not have any confusion since doing the non-alkyl substituent. Okay, they're pretty straightforward. But when we come to the alkyl substituents, they get a bit messy. So first of all, I will talk about simple cases. Okay, simple cases. Number one, if I take an example, So here we have our functional group. So our parent carbon chain will be something like this. I hope you can see it right now. Right. So 1, 2, 3, and 4 carbon atoms. Now the substituent will be this carbon atom. That is only one carbon, so it will be meth. We'll call it meth. And because it is one carbon atom, so meth, and YL because it is a substituent. So methyl is a simple case. Second, let us suppose you have something like this. So obviously your parent carbon chain will be starting from this carbon atom. It will go this way and it will go towards the double bond because we have to give priority to the double bond. So you have 1, 2, 3, 4 carbon atoms, and this is your carbon, which is a substituent. So how many carbons here? Please tell me, guys. In the substituent, how many carbons? In this substituent, how many carbons do we have? Are you guys getting this, or I'm going too fast here when I talk about substituents? Should I go slowly? Tell me, guys, Deborah, Hafsa, Fia, should I go slowly? Yes, tell me, guys. Madiha, Mariam, Rabia. I'm not getting answers. Please tell me in the chat now. Yes, Mariam Khatun, correct. What about others? Hafsa, how many carbons here? Yes, Iram, correct. Madiha, Tarif, Rabah, and Rabia. Please send your answers, guys. 2 carbons. So what's the word for 2 carbon atoms? What's the word for 2 carbon atoms? Eth. Very good. Eth. And we will add YL to get substituent. Now tell me, Hafsa, am I going too fast here when I talk directly about the substituent? Should I go sequence by sequence, functional group, unsaturation, parent, and then substituent, or I can talk about substituent directly? Hafsa, tell me. Hafsa, is this too fast or is it okay? Oh, at least tell me something. If you will say it is too fast, I will go slowly. Madiha, you tell me. Madiha, you tell me. Is it fast or?
So it's fine, sir.
It's fine. Hafsa,
Yes.
what about you? Hafsa, please answer. Hafsa is also new. Hafsa, please answer.
Yes, sir. It's fine.
It's fine. Okay.
Yes.
Thank you. So when you have simple cases, then it's going to be very easy. You don't have to worry about it. Okay. But there are a few common names that we use. Okay. And you will see most of them when they have written a word. For example, they will write when tert butyl chloride reacts with alcoholic KOH, then what is the product? Okay. So tert butyl chloride. That is not IUPAC naming. So how will we understand those type of names? So please see, very important concept is the different points of attachment. What I say? Points of attachment. Points of attachment to parent chain. Okay. Points of attachment to parent chain. Fia, where were you? You missed a bit. See these two. You understand it is methyl and ethyl. Yes, Fia. Look at these two examples. Fia, do you get this? Yes or no? Please tell me. Fia is not audible. Points of attachment to the parent chain. Okay. So I will start with a simple case. Please don't write anything.
Sir,
Yes, tell me. Yes.
sir, I had a bad network connection, sir, so I had to reconnect it.
Okay,
Can you
fine.
explain this code, sir?
Yes, tell me. You look at this now and try to see that I have identified substituent as methyl and here we have ethyl. Try to understand. We will start from functional group. Then we will look at unsaturation and then choose the parent carbon chain. Whatever remains is what? Whatever remain is substituent.
Okay, it has because 2 carbons, so it's ethyl. Okay.
Got it? Now, one more case I will tell you guys. For example, if you have something like this. Okay, so the parent carbon chain will be pent. Now here you have two substituents. So what is the substituent here? What will be the name now when you have two carbon atoms? When you have something like this, what we will call this? Yes, Tarif, correct. Okay, Khatun, yes, correct. I'm correct, very good. Now, some people, they get initially confused. They say that, okay, fine, we have two carbon atoms, so we'll write ethyl. No, this is not ethyl. Ethyl is when you have two carbon atoms together. So what is the substituent here? Substituent here is methyl. And you have to look at what is the substituent. This is methyl. What is the substituent? This is methyl. And what about this one? This is also methyl. So in order to write it in a short way, we'll write dimethyl. Okay, now one more thing. This D word, this D letter, it should not be considered in the alphabetical order because di, it is not a name of substituent. Dimethyl is no substituent. Methyl is a substituent. Di tells you that there are two methyl groups. So dimethyl is not a substituent. Please understand that. Okay, methyl is a substituent. So when you are numbering, when you are naming things, and you have to write the substituents in alphabetical order, and you have to also write the substituent in alphabetical order. So in that alphabetical order, you will be using M for methyl, not D, because dimethyl is not a substituent. What is the name of substituent? Methyl is the name of substituent. All of you got this? Yes or no? Please, we will take examples, but please write this also. Then we will take a bit more complex cases where you have point of attachment of parent carbon chain. It's a bit complicated only, and it's going to help you a lot, by the way. I hope everyone has written this down. Can I move on? Yes or no? Please tell me. Can I move? Okay, please let me know if someone is writing. Please say yes if someone is writing. No one is writing. Fine. Now, please leave your pens aside. Don't write anything. Don't write anything and listen. Points of attachment to parent chain. So first case I will take is the case of 3 carbon atoms. So obviously, when you have 3 carbon atoms, the substituent will be propyl, but it will be different types of propyl. Please see here, don't write anything. So I have propyl, this is my norm, this is propyl. And if propyl is attached with one of these carbon atoms, and one of these, any one of these, so I will take only this one, just attach on this carbon atom, and then it will be known as N-propyl. That means normal propyl. Okay, normal propyl, or you can directly write or propyl only. If you write propyl, it suggests that the substituent is what? The substituent is normal propyl. The point of attachment is one of the terminal carbons. One of the terminal carbons. So for example, if I have a parent carbon chain, something like this, I will take the example of cyclohex here. So we have cyclohexane and it has been attached with propyl group. So how it will be attached? Like this. So right, you can see the point of attachment of propyl group is what? It is one of the terminal carbons. Is this clear? Yes or no? Please tell me first of all. This is clear?
Sir, but it won't be like butane because it's like 4, right? 1, 2, 3, 4 if you count.
If I count 1, 2, 3, 4, count.
Yeah, 1 carbon is already attached with the that group, benzene. So it will be 4.
That's not benzene first of all. Okay, wait a second. 1 carbon, 2 carbon, 3 carbon, right?
Yeah.
But I understand that don't. Ekdam udas ho gayi, yeah? Fia got disappointed. Fia, listen, no problem. It happens. Don't worry. You may see that this 4th carbon also is a part of, but no, it is part of the ring. That will be your parent chain, right?
Yes, sir.
Okay, आंखों का धोखा है ये और कुछ नहीं, it's just an illusion that you see 4 carbon. Oops, my bad. Okay, so it will be 3 carbon atoms. So the name of this will be very simple. It will be 1 propyl cyclohexane. Okay, now I'm not worrying about the naming here, but I want all of you guys to understand the point of attachment here. Okay, now the next point of attachment, we have only 2 carbon atoms here. If I essentially see in a propyl, we have 2 types of carbon. One is these red carbon atoms, they have similar property, and then you have the middle one, that is the green carbon atom, which is having a different CH2, right? So point of attachment to N propyl, and another case can be this carbon atom. If the parent carbon chain is attached to this particular carbon atom, then we call it isopropyl. Isopropyl is directly like this, isopropyl. Okay, so isopropyl, how will be the point of attachment? PC. Now this will be attached with propyl group like this. Now this name, this particular compound, it will become isopropyl cyclohexane. Isopropyl cyclohexane, we can add 1 here in order to number it. All of you understood this? Yes or no? Please tell me. Tell me, guys. Understood, na? I hope this is not very tough. You can see isopropyl, right? You have, what is the substituent? Here you have substituent like this. 3 carbon atoms and attached with this middle carbon. Right? Now, you can also see this isopropyl, N-propyl in the case of common names. For example, if they say N-propyl chloride. That means chlorine is attached to normal propyl normally. So 1, 2, 3, and in one of the terminal carbons, you will have chlorine group. If they say N-propyl, isopropyl chlorine, then you have propyl like this, and chlorine is attached in the middle carbon. All of you understood this? Yes or no? Please tell me. Similarly, you can have also something like this, isopropyl alcohol. So it will be having isopropyl alcohol is OH group. So these are common names. And you will see a lot of common names, but you have to have a kind of idea what they are trying to say. So 3 carbon atoms, is this clear? Yes or no? Please tell me. Please write this down. If you have not written yet, I will just wait a few seconds. Okay. Please let me know if someone is writing. Please say yes if you're writing. Please say yes if you're writing. Achha. Fia is writing. Okay. Fia, you will let me know once you are done. Done, Pia? Pia, are you done?
Yes, sir.
Now let's take the case of 4 carbon atoms. Four carbons will always have butyl as substituent, but it can be different types of butyl. First of all, you will have normal butyl, right? This is normal butyl. N-butyl, or you can just write butyl. Then here in the same type of structure, if I see there is another carbon atom. So here we have 2 types of carbon atom. These red are one type of carbon atom and these greens are similar type of carbon atom, right? The red ones are CH3, and the green ones are CH2. So when you talk about the CH2 carbons, either this point of attachment or this point of attachment, anyone, it's the same only. I have utna aap log ka khud se, I mean that much part you have to understand yourself how it is same and how it is not same. Okay, so CH2 it is same. Now this is a secondary carbon. As you can see, this is 2 degree. It is attached with 2 different carbon atoms, so we call it sec-butyl. We call it sec-butyl. And for example, if you have something like this, we have one, or here we are having carbon atoms like this, and then here we have another carbon atom. So here also, how many carbons? 1, 2, 3, 4 carbon atoms. So this is also butyl only. This is also butyl, but this butyl has 2 different carbon atoms. This red ones are 1 carbon atom, 1 type of carbon atom. All of them are same. And then you have the middle carbon, which is blue I have written, that is a different carbon atom. I'll first of all take the red carbon atom. So when you see the red carbon atoms, it is very similar to the iso group. Because if you are going to part it like this, you are going to get 2 CH3. So whenever you divide something and you get 2 CH3, it is iso. So now this will be isobutyl. And here only we have another carbon atom, which is this middle one. Now this carbon atom is attached with 3 different carbon atoms. That is why it is known as third butyl. Or you will also see something like this, T-butyl. Okay, so the examples you can see. For example, you have N-butyl chloride. So you'll draw butyl and then you will attach chlorine in one of the end carbon atoms, terminal carbon like this. If you have sec-butyl chloride, then you'll make butyl and you'll attach chlorine as the one of the secondary carbon atoms. If you have isobutyl chloride, bromide, let us take. Then you will draw the isobutyl group like this. And see, if you attach chlorine here, then also it is fine. If you attach chlorine here, then also it is fine. If you attach chlorine here, then also it is fine. All of these are cases of what? Isobutyl bromide. Sorry, Br you have to attach, my bad. In this case, you can write T-butyl chloride. So you'll make tertiary butyl group like this, and you can attach chlorine here. That's it. Is this clear? Yes or no? Please tell me. All of you guys, please tell me. Fia, Hafsa, Madiha, Mariam, Tarif, Iram. Is this clear?
Yes, sir.
Okay. Please write this down. Let me know once you're done for 4 carbon atoms. Okay. Now write next, that is for 5 carbon atoms. So the substituent is always going to be known as pentyl, but there will be different types of pentyl. And the first one, I hope all of you have now got an idea. It is normal pentyl, in which the point of attachment is one of the last carbon atom. Right. So either this one or this one, since both are the same, we will write one of them only. So example would be, this is N-pentyl or just pentyl. So if you have pentyl bromide, then they want you to write this structure. Another one is isopentyl. So isopentyl, what you need to have? You need to have CS3 group like this. And then you have 1, 2, 3 carbon atoms, 4th carbon atom here. And 5th carbon atom here. Okay. And the point of attachment is here, this carbon atom. So CS3 is necessary. So this is isopentyl. For example, if you have isopentyl bromide, you will write it like this. Okay, but if you arrange it in a different manner, then it will look something like this. 1, 2, 3. Oh, sorry, my bad. There will be one more carbon atom. Br will be attached here. 2, 3, 4. 4 carbon atoms, and like this, and this is Br. Okay, so this may not look like what this may not look like isopentyl bromide, but it is one. As you can see, here we have the Br, as here we have, right? Or should I have one more carbon atom? I think there is one more. 1, 2, 3. Ek aur carbon atom. My bad, guys. I missed one carbon atom here. This will be like this, Br. So you have 1, 2, 3, 4, and there is one carbon atom. So this is CS3. This CS3, as you whenever you see this type of bonding, this is a type of iso bonding. Okay, this will be 1, 2, 3, 4, 5 carbon atoms. So it is isopentyl bromide. So don't just get shocked when you see this type of structure and they have written isopentyl bromide. Okay, so this can have IUPAC naming, but we are not worrying about that right now. I want to cover some common names also, because you will see that in many of the questions. Next, we have neopentyl, which is very important. Now, neopentyl is something like this. You have all the 4 carbons attached to one carbon atom. That will make 5 carbon atoms, right? And then all the 4 carbon atoms are same. So any one of the carbon atoms will have the group attached. So this is known as neopentyl. For example, if you have something like this, 1, 2, 3, 4, 5, and this carbon is having Br. So this will be neopentyl bromide. Please write this down. Let me know once you're done. Is everyone done? Yes or no? Please tell me. Let me know once you're done, guys. Got the structure again? Okay, thanks. See, here you have 1, 2, 3, 4 carbon atoms, and one is in the middle. So it is 5 carbon atoms. And then you can also see this 1, 2, 3, 4 carbon atoms, all of them are same. When you attach in anything on that one of those carbon atoms, 1, 2, 3, 4, then it is neopentyl. That's it. Okay. So pent means you should have 5 carbon atoms, and you have 5 carbon atoms like this. And one of these carbon atoms, any one of these carbon atoms is attached, then there is the point of attachment. In any one of these carbon atoms, we have the point of attachment. We can take this carbon also, because all the carbon atoms are same only, no? All of these are CS3 until unless you attach something. Or here. You got this? Yeah, yes or no, please tell me. You'll have to train your eyes in order to identify it very quickly. It is going to take time right now, but as soon as you see neopentyl, then you should write you should know what is neopentyl. Maybe you cannot identify when you see the structure, but when the name is given isopentyl, neopentyl, N-pentyl, or third butyl, all of these things, you should be able to understand what is the structure. I will do just one question right now, and then I will end this class today. For example, if you have, let us suppose something like this. A double bond here. Okay. Now, what is the functional group? There is no functional group. That is why I will write E. Unsaturation. Here we have a double bond. That is why I will write En. And the parent carbon chain. So parent carbon chain should contain the double bond. So I'll start from this carbon atom and I will move like this. Now, once I have chosen the parent carbon chain, I will count it. Counting and numberings are very different. When I count, I don't have to look where I'm putting the numbers 1, 2, 3, 4. I just need to count it. Okay, so I'm just counting right now. I'm not numbering it. 1, 2, 3, 4, 5, and 6. So 6 carbon atoms, that means it is going to be X. Now I need to see the substituent here. So what is the substituent? I will see that, okay, fine, this is my substituent. How many carbons here? I have 1 carbon, 2 carbon, 3 carbon, and 4 carbon atoms. So 4 carbon, that means it is one of the butyls. So can you tell me guys in the chat, what type of butyl is this? In the chat, please. It is a butyl, but what type of butyl is this? Please look at the point of attachment and tell me what type of butyl. No, butyl it is not. Yeah. It is not pentyl, it is butyl. It is butyl. 4 carbon atoms only. Yes, Tarif, correct, very good. No, Mariam Khatun, please see once again. Yes, Fia, correct, very good. Mariam Khatun, please, dobara dekhi, please. Look at the point of attachment. Where is the carbon attached? This is the carbon atom. Yes, Fia, you are correct. I want answers from other people also. Iram, Madiha, Hafsa, Rabah, and Rabia, please answer, guys. Yes, Mariam Khatun, you identified it correctly now. Very good, Mariam Khatun. Okay, so the point of attachment is an important concept that you have to understand. Yes, Hafsa, very good. Very good. It's crystal clear, Hafsa. Yes or no, please tell me.
Yes, sir.
Right? Other than practice, you guys don't need anything right now. Okay. So you just need to practice it a bit. Now, substituent is what? It is third butyl. So I will write T-butyl, or you can write third butyl, both of them. I will write T-butyl. Once I have named SPUF everything, then I will start numbering. So obviously numbering should start with the carbon atom that is having the, that is nearest to the functional group. If no functional group, then the unsaturation. So I can have numbers something like this. I can start with 1, 2, 3, 4, 5, 6. That is one numbering that I can do. Another numbering that I can do is the other way around. 2, 3, 4, 5, and 6. So tell me which one should I do? The red one or the white one? Which one should I do? See, the En is getting the first. I mean, En will be one En only. right? The next thing that you have to look is the substituent, because En is getting number 1 in both the cases. In white also it is getting 1, and in red also it is getting 1. So next you have to look at the substituent. So where is the substituent getting less number? Is it getting less number in the red or the white case? You have to look that. Where is the substituent getting less? See, double bond is always getting number 1. So double bond cannot be the one which is going to, which is not going to be the tiebreaker here, because it is getting 1 for the red also and 1 for the white also. But if you look at the substituent, it is getting 4 in the red case and 5 in the white case. So I will take the red numbering, not the white one. I hope this is clear. Okay. So now here you can see that the third butyl will be 4-T-butyl. And the name will become 4-tertiary butyl or third butyl. X1E. Okay, so that will be the name. Right. So we'll do a bit of more practice tomorrow. I don't have questions with me right now. That is why I could not give you guys any questions. But what all of you guys can do is you go to your app. Okay, you go to your app. Please ignore the benzene structures as of now. You'll not be able to name the benzene structure. Tomorrow we'll do some practice questions and the benzene structure also. So I should have given you the homework, but I could not get the structures right now. So what you guys can do, you guys can go to your Learnivio app. Okay, fine, Rabba. I will scroll up. How much up, I don't know. So if you want to see this, so you'll go to your Learnivio app and you have class assignments. Okay. So in assignments, you will see that most of the thing would be activated. You can go to the chapter haloalkene. All the organic chapters. Okay. Haloalkene, you can go alcohol. You can go to aldehyde, ketones, and carboxylic acid, right? You can also go to what? You can also go to amines. Okay. For amines, we'll do a bit of practice. Amines, when we go to the amines chapter, you will have some doubt there, but we will clear that up. It's not very difficult. There is a bit of new information that you need to know in order to name the amines, right? But all of the above chapters here, haloalkene, alcohol, aldehyde, ketones, and carboxylic acid. So if you go to the class assignments, one of you please go to the class assignment part there? Should I show you guys? Maybe I should show you guys. Wait a second. Let's see if I have signed in my. I have signed in. I have signed in here. You guys must have. Fine. Yeah, here. Just a second.